we know, the entire electrical power system is protected by using different protecting devices like fuse, circuit breakers, lightning arresters, etc. Not a single part of the power system remains unprotected. Circuit breaker is a device used for protection as well as switching purpose. That means we can switch on or switch off electrical circuits by using circuit breakers. And it also provides protection to electrical circuits against short circuits and overloads. Protective relays are used as a sensing device. Relays sense the fault in the electrical circuits and it will give trip command to the circuit breakers. After receiving the command from the relay, circuit breaker will open its contacts so fault current will not reach to the electrical circuits and therefore it avoids the further damage. In this video, you will learn how relay will sense the fault and circuit breaker will operate to open the contacts. Suppose a line is connected to the bus bar and a circuit breaker is inserted for protection purpose. A current transformer is connected to the line. The primary function of the current transformer is to step down the high current to a manageable level in the range of 1 to 5 amperes. Current transformers are very important for protective relays, where they detect fault currents and trigger protective relays to isolate faulty sections of the electrical networks. In this circuit, the primary side of the CT is connected to the protected line and secondary side is connected to the relay coil. A soft iron plunger is connected in between the relay coil, which is electrically isolated from the coil. Electrical isolated means no current flows from the plunger. When relay coil energized or magnetized, the iron plunger attracted, and when relay coil de-energized or demagnetized, the iron plunger will be released. Now you can see a separate circuit is drawn just above the plunger. This circuit is called trip circuit. This circuit contains DC power supply, a trip coil and two contacts. The contacts are placed just below the relay coil plunger. The trip circuit can be closed only by the relay coil plunger. The trip circuit contacts are normally in open conditions. A separate plunger is placed in between a trip coil, just like the relay coil plunger. It can control the opening and closing of the main line contacts. Trip coil contacts are in normally closed condition. Now we will see operation of trip circuit. Assume that normal current is flowing through the bus bar. As a result, a small amount of current will flow through the CT secondary and relay coil. So, magnetizing effect of relay coil is very low, which is not sufficient to attract the relay coil plunger, and therefore the trip circuit will not energize at normal condition. Now assume a fault is occurred in the line. So, a huge amount of the current will flow from bus bar to the line. And according to the CT ratio, it will also carry a large amount of current from CT secondary to the relay coil. With the increase in the current of relay coil, the magnetizing effect of the relay coil will also increase and it attracts the plunger. The plunger will close the trip circuit and a current will flow through the trip coil. By flowing normal current through the trip coil, it gets energized. As a result, the trip coil plunger is released and finally the circuit is open with the opening of the circuit breaker and current stops flowing. After that, the CT and relay coil will sense no current and relay coil de-energized. As a result, the relay coil plunger will be released. Then no current will flow through the trip circuit and trip coil will de-energized, and therefore the trip coil plunger is attracted to close the contacts. Now you can see the main line is closed and normal current is flowing through the bus bar. From fault sensing by the CT to operation of the circuit breaker, it requires less than 1 second for operation of the whole process. This is about the entire process of the trip circuit of circuit breaker. Thank you.